This is our first video lesson for Math 90. We're going to start by working off a handout called Equations, Graphs, and Symmetry. The handout is posted as a PDF in Canvas. This material is not in the textbook, so you need to rely on the handout for the classwork and the homework. We're going to start the course by talking about graphing. In fact, a lot of this course deals with graphing in the XY plane. And so make sure you have lots of graph paper. Here's some just sort of inexpensive graph paper I got, and I set up with a graph grid, an X and Y axis. Oh, it's always good to label the scales on the X and Y axis. And we're going to do some exercises where we sketch some really difficult graphs. These are not obvious, and there's as you'll see. But the point isn't so much to get the shape exact on our first try. It's to just think a little bit, learn a little bit about what it means to explore an unfamiliar graph. Like, what would we do? So we're going to start out by looking at exercise 1. And the equation is x squared equals y cubed plus 1. We want to graph this equation. And I copied the exercise 1 on a separate sheet of paper here, so it's easier for us to see in the video. So one thing I would do if I were exploring a new equation that I'm unfamiliar with is I would just try to plot some points, come up with some point values. And the easiest way to get started plotting points is to look for x-intercepts and y-intercepts. You know that x-intercepts are points on the x-axis, and they have y-coordinate 0, so we actually have to set y equal to 0 to find x-intercepts. So let's take that equation, x squared equals y cubed plus 1. I'm going to set y equal to 0, so I get x squared equals 0 cubed plus 1, or just x squared equals 1 is what I end up with. A little quadratic equation that I can solve by taking square roots. X is going to be plus or minus the square root of 1. There are two square roots of 1, and we need to consider both of them here. X is equal to plus or minus 1. So I have x coordinate 1, y coordinate 0, and x coordinate negative 1, y coordinate 0. So we got 2 points. Now we're actually going to collect a whole bunch of points before we plot any and look at the graph. So let's keep going right on to part B here. Let's find the y-intercepts for this equation. So I do the reverse. I set x equal to 0 because y-axis points have x coordinate equal to 0. Take the equation again, and I'm going to set x equal to 0. So I have 0 squared, or just 0, equals y cubed plus 1. I want to isolate the y cubed, so I subtract 1 from both sides. I get negative 1 equals y cubed. To solve this equation, I need to take a cube root. The cube root of negative 1 is y. And just before we go further, I just want to point out, because sometimes students are thrown by this, that there's no plus or minus sign when cube rooting. And that's because real numbers have just one real cube root. This is very different from square roots, where square roots come in pairs. So the cube root of negative 1 is just negative 1. We get only one value of y. So when x is 0, y is negative 1, there's just one y-intercept. And let's keep going. Now, in real life, if you're trying to graph an equation, you just have to pick values of x and y when you're plotting points. There's no rule about which ones to pick. Here I'm guiding us along a little bit because I suggest that we set y equal to 2. And let's see what happens. So I'm taking my equation, x squared equals y cubed plus 1, and I'm going to plug in y equals 2. So I have x squared equals 2 to the third power is 2 times 2 times 2 are 8 plus 1. x squared equals 9, another quadratic equation that I can solve by taking x equals plus or minus the square root of 9. So x is equal to plus or minus 3. That comes out even. And so let's see, I got 3 comma 2, because y was 2. And I have x coordinate negative 3 comma 2 also. So I got 2 more points on the graph. And again, we'll plot these once we've collected all our points. So let's go right ahead to part D of this exercise, where we're going to find all points on the graph for which y equals negative 2. So I have x squared equals y cubed plus 1. There's my equation. If I plug in negative 2 for y, I get x squared equals negative 2 cubed plus 1. Or x squared equals now negative 2 to the third power is negative 2 times negative 2 times negative 2 is negative 8, a negative number. So I get x squared equals negative 8 plus 1 is negative 7. So there's a bit of a problem here, right? Because when I take square roots, x is plus or minus the square root of negative 7. That's not a real number. It's not a real number. And because you can't take a square root of a negative number in the world of real numbers, and real numbers are the only numbers that appear when we do graphing. There are no imaginary numbers, if you've heard of those before. So there are no solutions. And that means there are no points with y equals negative 2. So it's a little bit disappointing, but it does tell us something about the graph. The graph never touches the point y equals negative 2, or never crosses where y is equal to negative 2. And now let's look at E. Find and plot all points on the graph for which x equals 2. Okay. Take our equation again and set x equals to 2, right? So 2 squared equals y cubed plus 1. 4 equals y cubed plus 1. Subtract 1 from both sides. I have 3 equals y cubed. So I'm back in this situation of having a cubic equation to work with. And so the cube root of 3 is y. Now that doesn't simplify algebraically. I could just say I have the point 2 comma the cube root of 3, but that doesn't exactly tell me where to plot that point, right? So you want to make sure you know on some sort of scientific calculator how to calculate cube roots. Let me know if you don't know how to do this, because for plotting here, we need to figure out that this is about 1.44 is the cube root of 3. And one more time we're going to go through this equation, plugging in a value. Here in part F, we're going to plug in negative 2 for x. And notice when we square negative 2, we get 4 again. 4 equals y cubed plus 1. This equation looks just like the line above. I have 3 equals y cubed. So the cube root of 3 is y. Again, no plus or minus with cube roots, right? There's only one. And the difference here is we plugged in x equals negative 2. We got the cube root of 3 for y, which of course is the same y value as before, about 1.44. So I'm actually going to stop the video right here. We've gotten all these solutions. In the next part of the video, we're going to plot the points and draw our graph.